Alright, today I'm going to be giving you a quick overview of a command line interface tool that I built for processing sleep tracking data of larval zebrafish to output the times at which specific bout types happened during the input video. I know that can sound a little bit complicated, so I'm going to show you the pipeline really quick. So we start off with a top-down video like this with the larval zebrafish swimming around their enclosure. And eventually, we're looking to be able to classify these specific swimming movements of each individual fish into specific categories of bout, and also output the time at which each of these bouts occurred. So initially, we're going to take this raw video and we're going to input it into a framework called SLEAP. So this framework is really popular, and it's a deep learning software for general purpose multi-animal limb tracking from video. So after Sleep processes this video, it's going to output a CSV file similar to this one. As you can see on the left-hand side, we have a column called track. Now we have tracks 0 through 7, which means that Sleep identified 8 different fish in the video. We have the frame index, so this is the frames at which each of these data were collected. And we have some really interesting information over here. So as you can see, Sleep collects the X and Y coordinates of the nose of the fish, as well as the score of the nose. And the score is just the certainty that these coordinates are correct. Now we also collect the X and Y coordinates of the right eye, as well as the score, the left eye and the score, the swim bladder and the score. And then we also collect information on 7 different tail points. So as you could probably see from the video earlier, the larval zebrafish have really long tails, and it turns out that tracking the movements of these tails is really useful for helping us determine when bouts occur and what types of bouts occur. So we take 7 points along the zebrafish's tail. We get their coordinates as well as the associated score for each point. Now, that's what Sleep outputs. Now, my tool takes that CSV file as input, and it processes that data to output useful information for us. So let's run our command line interface tool. As you can see, it says Megabouts Multi-Track Analysis Tool, and that's because this tool is built using a Python library called Megabouts, which uses machine learning libraries like scikit-learn and PyTorch to analyze data. And this library is specifically built for analyzing zebrafish data. So it's asking us for the relative path, if I can remember the name. And it's going to load that data. It's going to show us the available tracks in the data, 0 through 7, meaning there are 8 different fish that we can analyze. And now we can select which fish we want to analyze. So we can select a single fish, a range of fish, or a list of fish. For this example, I'm just going to do 3 through 5. This is asking for a certainty threshold, which means if we go with the default 0.5, we won't be outputting any bouts that had less than a 50% certainty. So that sounds good for now. These configuration settings are good. It asks us to enter the number of tail points. So as I showed you earlier, we are keeping track of 7 tail points. And now it's processing track 3, track 4, and track 5, and it's done. So if we take a look at this output really quick, we can see that track 3 had 2 different bouts. We had one at almost 0 seconds and one at about 6.2 seconds. To clarify, this video I believe was only about 8 seconds, so these are at 2 different ends of the video. We have the category for both. They happen to both be LCS, as well as the certainties. We had 99% certainty for the first one and 96% certainty for the second. If we take a look at track 4 here, we can see that there were some more bouts in this one. They occurred at a range of different times across the video, and we got a range of different categories. So we got RT, S1, LCS, JT, some different categories, as well as their associated certainties on the right. For track 5, we can see we actually got a lot more bouts. Once again, they occurred at a range of different times. We got some different categories, and we have their certainties on the right-hand side. So our analysis summary here, we can see that we successfully processed all 3 tracks, and we found a total of 28 tail bouts with a certainty of greater than 0.5. So if we increase that certainty, we would get less bouts. If we decrease the certainty, we would get more bouts. It asks us if we want to save the results to a CSV file. I guess we'll just show off that functionality real quick. So let's save it to results.csv. It saves it to that CSV file, and let's just quickly take a look. And as you can see, we have our 28 bouts. On the very left hand side, it shows us the track number, or the fish. It shows us the onset frames and the onset seconds, which just tells us when the bout started or when it occurred. Gives us the category as well as the certainties. So that's pretty much the overview of the tool and its functionalities. I'm going to quickly show you the code because it is quite an extensive file. There are hundreds of lines in this file, and that's mainly due to lots of user prompting and exception handling. Now, I'm not going to go into detail on any of this code, but if you're curious, it is going to be linked down below to my GitHub. And I'm also going to leave a link to the Megabouts machine learning library because it was really useful for this project. And so if you're interested in doing something similar, you should definitely check that out. All right, thanks for watching.